Hi and welcome back. In this video we're going to talk about binary trees. A binary tree, like a list or a set, is another data structure that we can use to hold some values. However, it's structured a little differently from a list. Let's have a look. In the last video, we looked at binary search, where we started at the middle of our list and then sort of constructed an algorithm that allowed us to search. If you take the values that this algorithm comes up with, you actually end up with a binary tree. Let's have a look. If you start at the middle of this list and you take the first value, let's make that value the starting point of our tree. So we'll just move it down, and this is going to be the starting point. In binary search, we then discarded one half of these values and moved over to the middle of the remaining segment. We're going to do, without discarding any values, we're going to do that for both segments. So we're going to move over to the middle of the remaining segments. So we're going to start at the middle of each segment here, which takes us to 7 and 59. And we're going to take those two values and we're going to make them appear underneath 38. So this tree is now starting to be constructed. 38 has sort of what we say two children, 7 and 59. 7 is at the left, 59 is at the right. If we do this again, now we're going to end up with 4 values, because we're going to move over to the middle of the remaining segments in each case. And once again, we're going to move these values down and make them children of the previous one. So now 7 has 2 children, 59 has 2 children. Once again, we're going to repeat and get the half point of the remaining segments. Now we end up with 8 values. And we move them down here. And finally, there's not that many left. There's not 16 values left. So we're going to move over to the remaining few values and we're going to move them down as appropriate. So as you can see, we end up with something that looks like a tree. If we add the branches in, it becomes a bit clearer. We have elements that have children below them. And a child can then have children as well. It can have 2 children or it can have 1 child. And what happens is every node has an element or another node that is smaller than it to the left and another node that is bigger than it to the right. Take an example of 38. It has the node 7 to the left, which is smaller than 38. And it has the node 59 to the right, that is bigger than 38. So with this structure, we can very easily perform a binary search. So the binary tree is used to perform binary searches. Let's look for the element 90. 90 that you can see is down there on the right. To perform a binary search, now all we have to do is start at the top of the tree and then decide whether we want to go left or right. Because 90 is bigger than 38, we'll go right. Then, because 90 is bigger than 59, we'll go right. And now 90 is smaller than 717, so we go left. And that's it, we found it. So it's just the same as performing a binary search. The binary tree is structured in this way so that we can search easily, and we end up with smaller elements on the left, larger elements on the right, and we just have to sort of go through each. Of course, the binary tree has to be ordered in this way for it to work. We're going to look at how to create binary trees like this in the next few videos. So once again, the binary tree is just, well, you can think of it as a representation of the ordered list after you perform a binary search on it. If you take the binary tree left to right, notice how the leftmost value in this tree, the one at the very left, is the number 1. And the next value to the right is the number 3. The next one is number 4. The next one is number 5. And the next one number 7, and so forth. So if you take the entire tree and you put it left to right, what you end up with is once again your sorted list. So this is a pretty interesting piece of knowledge. You may not find yourself using binary trees all that often in your software development careers, but nonetheless, they are sort of everywhere when you do software. You've got them in databases, you've got them in when you need to search through large lists. And so it's interesting to know about these binary trees. In the next few videos, we're going to learn about how to construct binary trees, how to search through a binary tree in code, and so on. So hopefully, what a binary tree is makes sense. It's just a structure that has branches where the larger branches to the right, the smaller branches to the left, and that allows us to produce and to very easily implement a binary search algorithm. That's it for this video, and I'll see you on the next one.